Welcome to Astronomy Daily. I'm Anna, and I'm thrilled to bring you the latest developments from across the cosmos on this beautiful day. Today, we're exploring a fascinating range of stories that highlight humanity's ongoing relationship with the stars. From cleaning up our own orbital neighborhood to dreaming of interplanetary expansion, our species continues to push the boundaries of what's possible in space. We'll start with some promising news in the battle against space debris. ClearSpace has just completed the second phase of the UK Space Agency's active debris removal mission, demonstrating technology that could soon help us clean up the growing problem of defunct satellites in low Earth orbit. This is crucial work as our orbital highways become increasingly congested. Then, we'll dive into Elon Musk's latest comments about Mars colonization, where he takes an extraordinarily long view of humanity's future. His perspective on why we need to become a multi-planet species might surprise you. It's not just about immediate threats, but about the sun's inevitable expansion hundreds of millions of years from now. We also have exciting news from the moon, where the Japanese company Ispace has successfully placed its Resilience lunar lander into lunar orbit. This achievement brings them one step closer to a landing attempt scheduled for early June, which would mark a significant milestone for private lunar exploration. The search for extraterrestrial intelligence continues to fascinate scientists and the public alike. We'll examine a new mathematical approach to the famous Fermi paradox that offers an intriguing perspective on why we haven't heard from alien civilizations yet, despite the statistical likelihood of their existence. And finally, we'll explore a cosmic mystery that astronomers are beginning to unravel. A black hole system nicknamed Ansky is producing powerful X-ray bursts every 4.5 days, and NASA's NICER telescope has helped scientists determine what might be causing these regular cosmic explosions. These stories represent the cutting edge of our understanding of space and our place within it, from the practical challenges of orbital debris to the philosophical implications of becoming a multiplanetary species. So let's blast off into today's cosmic journey. First up, ClearSpace has reached a significant milestone in tackling the growing challenge of space debris. The company recently completed the second phase of the UK Space Agency's active debris removal mission, showcasing promising technologies designed to clean up our increasingly cluttered orbital environment. During extensive mechanical testing, ClearSpace's robotic capture system demonstrated its ability to withstand the extreme forces experienced during rocket launches. This is crucial since any debris removal system must first survive the violent journey to space before it can begin its cleanup mission. The company also made significant progress with its image processing algorithms, proving they can effectively detect and track space debris. This capability is essential for any mission aiming to capture defunct satellites, as these systems must be able to identify and monitor their targets with precision in the challenging environment of space. Perhaps most impressively, ClearSpace successfully demonstrated proximity operations using a hardware-based spacecraft emulator. This simulates the delicate dance of approaching and capturing a tumbling piece of space junk, one of the most challenging aspects of debris removal. Beyond the technical achievements, ClearSpace completed detailed programmatic estimates that provide the UK Space Agency with valuable insights for planning future missions. This comprehensive approach is helping to build a sustainable framework for addressing the space debris problem. Ray Fielding, who heads sustainability at the UK Space Agency, expressed delight at the successful completion of this phase, noting that an exciting period of innovation for space sustainability lies ahead. The Clear mission represents more than just a debris removal project. It's positioning the UK as a leader in the growing field of in-orbit servicing. ClearSpace isn't working alone in this endeavor. The company has assembled an impressive team of partners, including critical software from Portugal, Spain's Indra Demos, Plextech from England, and Spirit Aerosystems based in Kansas. These collaborations are helping to refine crucial technologies, from guidance and navigation algorithms to specialized radar systems for rendezvous operations. The competition to lead in space sustainability is heating up, with British subsidiaries of both Astroscale and ClearSpace vying for a UK Space Agency contract to remove 2 defunct satellites from low Earth orbit in 2026. This competitive approach is accelerating innovation in a field that will become increasingly vital as our reliance on satellite infrastructure grows. Next up, some musings from Elon. Elon Musk recently offered a cosmic perspective on his Mars colonization ambitions during an interview with Fox News host Jesse Waters. When asked about his fixation on the red planet, Musk framed his answer in terms of the ultimate long-term survival of life itself. That's one of the benefits of Mars, is life insurance for life collectively, Musk explained. His reasoning goes far beyond immediate threats like asteroids or nuclear war, extending to an inevitable astronomical reality. Eventually, all life on Earth will be destroyed by the sun. The sun is gradually expanding, and so we do at some point need to be a multi-planet civilization, because Earth will be incinerated. This isn't science fiction, but rather established astrophysics. Our sun, like all stars, is gradually getting brighter and hotter as it ages. Musk estimates that we have about 450 million years before it gets so hot that life is impossible on Earth. While that might seem like an impossibly distant future, Musk's point is that humanity should begin the process of becoming multiplanetary now, while we have the opportunity. The timeline Musk references aligns with scientific projections. In a few 100 million years, the sun's increasing luminosity will likely strip away Earth's atmosphere and boil off our oceans. The final death knell will come about 5 billion years from now when our sun expands into a red giant, potentially engulfing Earth entirely. This existential perspective helps explain the urgency behind SpaceX's ambitious Starship development program. The massive, fully reusable rocket system represents Musk's vision for making Mars settlement economically feasible. Despite the vast timescale before Earth becomes uninhabitable, developing the capability to establish a self-sustaining civilization on another planet presents enormous technical challenges that could take generations to perfect. Starship has already flown 8 test missions, with 2 launches in 2025 showing partial success. During these most recent flights, the Super Heavy booster performed well, but the upper stage of the vehicle, called Ship, exploded less than 10 minutes into flight. SpaceX is now preparing for a 9th test flight, having already completed engine firing tests of both stages. While critics might question the practical value of focusing on such a distant threat, when humanity faces more immediate challenges, Musk's perspective represents a uniquely long-term vision for our species, one that looks not just decades or centuries ahead, but hundreds of millions of years into the future. It's a reminder that while Earth is our home, the ultimate survival of life as we know it may depend on our ability to spread beyond it. In exciting lunar exploration news, the Japanese company Ispace has successfully guided its Resilience lunar lander into orbit around the moon. The spacecraft achieved this crucial milestone on May 6th after performing an approximately 9-minute burn of its main thruster, the longest such maneuver by the spacecraft to date. This orbital insertion marks the 7th of 10 planned milestones for the Hakuto RM2 mission, which began with pre-launch preparations back in January. The final goal will be reaching a steady system state on the lunar surface after landing, which is scheduled for no earlier than June 5th. Resilience took a fascinating journey to reach lunar orbit. After launching on January 15th aboard a SpaceX Falcon 9 rocket, the spacecraft followed a fuel-efficient, low-energy trajectory that minimized propulsion requirements. This path included a lunar flyby on February 14th that took the craft an impressive 1.1 million kilometers from Earth before it returned to enter lunar orbit. The landing target is near the center of Mare Frigoris, located at approximately 60 degrees north latitude. While this remains the primary landing site, Ispace has identified 3 alternative locations if needed, all of which would support landing attempts through June 8th. Resilience isn't traveling to the moon empty-handed. The spacecraft carries several technology demonstration payloads from Japanese companies and a Taiwanese university. There's even a small model house called Moon House, created by Swedish artist Mikael Genberg, making the journey. Perhaps most intriguing is the micro-rover named Tenacious, developed by Ispace's European subsidiary. This small explorer will venture around the landing site and collect lunar regolith. Under an agreement with NASA, ownership of this moon dust will be transferred to the space agency, representing an interesting demonstration of lunar resource utilization rights. This mission holds particular significance for Ispace as it follows their first lunar landing attempt in April 2023, which unfortunately ended in a crash due to a software problem. Takeshi Hakamada, Ispace's CEO, expressed pride in the team's successful orbital insertion, noting they leveraged operational experience gained from their first mission. The company already has ambitious plans for the future. Their next lunar lander is being built by their American subsidiary as part of NASA's Commercial Lunar Payload Services program, scheduled for a 2026 launch. This will be followed by another Japanese-built lander in 2027, showing Ispace's commitment to establishing a regular lunar presence. Next up, something to ponder. The Fermi paradox is one of astronomy's most fascinating conundrums. If our galaxy contains billions of stars similar to our sun, and many of these stars have Earth-like planets that could support life, then where is everybody? Given the age of our galaxy, approximately 13.6 billion years, there's been ample time for intelligent civilizations to develop and spread throughout the Milky Way. Yet we've detected absolutely no evidence of their existence. Named after physicist Enrico Fermi, this paradox highlights a puzzling contradiction. In cosmic timescales, it would take a technologically advanced civilization just a few million years to colonize the entire Milky Way, a mere moment compared to the galaxy's age. So, why haven't we heard from anyone? A new study by mathematician Matthew Civiletti from the University of New York is offering fresh insights into this cosmic silence. Rather than directly trying to solve the paradox, Civiletti has developed a mathematical model that assesses how likely it would be for us to have detected a signal by now if a certain number of civilizations were broadcasting. The model builds on the famous Drake equation, which estimates the number of active, communicative, extraterrestrial civilizations in our galaxy by multiplying several factors, from the rate of star formation to the fraction of planets where intelligent life develops, and how long such civilizations might last. What's particularly interesting about Civiletti's approach is that it uses our lack of detection as a data point. If his model suggests we should have a high probability of detecting signals given certain parameters, then our failure to do so becomes meaningful information that can help narrow down possible values in the Drake equation. The mathematics gets complex, but essentially, Civiletti's model explores the geometric aspects of signal detection and calculates the probability of detecting at least one signal. Under certain reasonable assumptions, his model predicts a 99% chance of detecting at least one signal if there's around one civilization broadcasting per the Drake equation parameters. This suggests that the absence of detected electromagnetic signals can place significant constraints on how many technological civilizations might exist. In other words, the silence itself is telling us something important about life in our galaxy. Despite being a basic model with certain limitations, Civiletti's work shows that even a lack of results from SETI, the search for extraterrestrial intelligence, can help rule out certain combinations regarding the number and lifespan of alien civilizations. This approach transforms non-detections from disappointing dead ends into valuable data points that refine our understanding of the cosmos. As SETI efforts continue and our models improve, we may increasingly be able to use this cosmic silence to better understand the conditions that make intelligent life possible and the factors that might limit its spread throughout the galaxy. The search for extraterrestrial intelligence isn't just about finding others. It's also a profound way to better understand ourselves and our place in the universe. Now let's explore another cosmic mystery that scientists are finally beginning to crack. Astronomers have been puzzling over a peculiar black hole system nicknamed Ansky that exhibits an extraordinary phenomenon: powerful X-ray bursts that repeat with remarkable regularity approximately every 4.5 days. What makes Ansky particularly fascinating is that it's the eighth known source of what scientists call quasi-periodic eruptions, or QPEs. But Ansky isn't just another member of this rare club. It's breaking records. Not only does it produce the most energetic X-ray outbursts among known QPE sources, but each eruption lasts an astounding 1.5 days, making it exceptional in both timing and duration. NASA's NICER, the Neutron Star Interior Composition Explorer, has been instrumental in unraveling this mystery. Mounted on the International Space Station, NICER observed Ansky about 16 times daily from May to July 2024, providing unprecedented monitoring of these X-ray fluctuations. This frequent observation schedule proved crucial in detecting and analyzing the patterns of these eruptions. So, what's causing these massive energy releases? The leading theory suggests that QPEs occur in systems where a relatively small object repeatedly passes through the disk of gas surrounding a supermassive black hole. When this smaller body punches through the disk, it drives out expanding clouds of superheated gas that we observe as X-ray flares. A team led by researcher Johin Chakraborty from MIT has mapped the rapid evolution of this ejected material in unprecedented detail. Their findings are remarkable. Each impact results in approximately a Jupiter's worth of mass being accelerated to about 15% the speed of light. As this roughly spherical bubble of debris expands outward, NICER's capabilities allowed scientists to measure both its size and temperature in real time. What makes Ansky different from other QPE systems may be the nature of its disk. Most QPE systems likely form when a supermassive black hole shreds a passing star, creating a small disk very close to itself. But experts like astrophysicist Lorena Hernandez Garcia suggest Ansky's disk is much larger, allowing it to interact with objects farther away and creating the longer timescales we observe. Scientists plan to continue observing Ansky as long as possible, as we're still just beginning to understand these fascinating eruptions. This research isn't just illuminating the behavior of black holes, it's also helping prepare for future missions like ESA's LISA, which will detect gravitational waves from systems where low-mass objects orbit much more massive ones, potentially transforming our understanding of these exotic cosmic phenomena. And that brings us to the end of today's cosmic journey. What an incredible collection of stories we've explored together. From ClearSpace's advances in space debris removal technology to Japan's Resilience lunar lander successfully entering orbit around the moon. We've contemplated Elon Musk's long-term vision for Mars colonization as humanity's insurance policy against the sun's eventual expansion, examined new mathematical insights into the Fermi paradox, and unraveled the mystery behind the rhythmic X-ray outbursts from the black hole system Ansky. Each of these developments represents another piece in our ever-expanding understanding of the universe. The challenges of cleaning up orbital debris, establishing a human presence on other worlds, landing on the lunar surface, searching for extraterrestrial intelligence, and deciphering the extreme physics around black holes, all reflect humanity's boundless curiosity and determination to explore beyond our planetary boundaries. I've been your host, Anna, and I want to thank you for joining me on Astronomy Daily. If you're hungry for more space and astronomy news, I invite you to visit our website at astronomydaily.io, where you'll find our constantly updating newsfeed with all the latest developments across the cosmos. There, you can also access our complete archive of past episodes if you'd like to catch up on any stories you might have missed. Don't forget to subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts to ensure you never miss an episode. The universe keeps evolving, and so do our stories about it. Until next time, keep looking up and wondering about our extraordinary cosmos. This has been Astronomy Daily, and I'm Anna, signing off.